So now that we've introduced the idea of theoretical probability, and that's really the probability of how likely an event is going to occur, we are now going to talk about the second type of probability, which is conditional probability. And the key term in that phrase is conditional. All right. And what that means in this case is that it's the probability of an event occurring knowing that an other event has already occurred. All right. So given events A and B, conditional probability is the probability of event B occurring, knowing that event A has already occurred. The notation for this is usually something like this: the probability of B given A. And that's exactly how it's read. The probability of B given A. So the formula to find this type of probability is as such. What is the probability of A and B occurring divided by the probability of A? All right. So let's look at an example like this. Mitchell drew a deck of cards from a standard deck of playing cards. What is the probability that he drew a queen given that the card was red? Okay. So in this case, what you need to recognize, all right, is what is event A and what is event B. A is the event that has already occurred. Okay. So A in this sense is the red card. Okay, that's given. B in this event is what they're asking us to find, drawing a queen. Now, in order to find the probability here, this conditional probability, the first thing we have to do is the probability of A and B. So the probability of A, which is drawing a red card, is 26 out of 52. The probability of B is drawing a queen, which is 4 out of 52. All divided by 26 over 52, which ends up being 1/13. Okay? All right, let's look at number 2 together. A number from 1 to 100 is randomly selected. What is the probability that it is a perfect square given that it's an odd number? So what's given, what event has already occurred is that they've already drawn out all the odd numbers. All right. So the probability of picking an odd number is 50 out of 100. All right. What they're asking us for is the probability that it's a perfect square. And the probability of that is 10 out of 100. We've got 1, we've got 4, we've got 9, we've got 16, we've got 25, we've got 36, we've got 49, we've got 64, we've got 81, and we've got 100. So to find this probability that you are going to pick a perfect square card given that it's an odd number, all right, well, that probability of A and B is going to be 50 over 100 times 10 over 100. And we're going to divide that of just the probability of A. And the probability of A is 50 over 100. So you have a 1/10 chance that you are going to draw a perfect square card that is an odd number. Okay, so let's look at number 3 together. There are 62 people that take a yoga class, and 48 people that take a spinning class at the gym. 15 people that take yoga also take spinning. So what's important is you're going to draw a Venn diagram here. Okay, so here's yoga, here's spin, and here's both. So we know 15 people take both, all right, which means that 47 only take yoga and 33 only take spin. If a person from these groups is selected at random, find the probability that he or she takes yoga if you know they take spinning. Okay? Find the probability that he or she takes yoga class if you know they take spinning. So the event that we already know is spinning class. Now, we know that the probability of the person taking spinning class is 48 out of 100. Okay? Now, our event of interest is that they take yoga. And the probability that they take yoga is 62 out of 100. So, what is the probability that they do both? All right. Now, the key thing here is that it's 15 people that take yoga and spin, which is actually the more important component of this. So B is not just yoga, it's yoga and spin. So in this case, it's really 15 out of 100. So to find this probability, it's going to be 15 over 100 times 48 over 100 all over 48 over 100, which gives us 15 over 100. So I want us to think about that. Did we have to go through all of this to get that answer? And the answer is no, because our train of thought here is incorrect. And let's talk about why. So, where did our error occur here? Why is this wrong? Well, the reason is because the numerator here is wrong. All right? The numerator stands for the probability of A and B. Okay? Well, A, we know, is taking the spin class, which means that B, all right, is taking the yoga class. All right? So what's the probability of taking spin and yoga? Well, we already know that. All right? We already know that. This is not correct. B is not yoga and spin. B here stands just for yoga. And we know the probability of that, all right, is 52 over 100. All right, but that's not what matters to us. What matters to us is the probability of A and B. How many people are actually taking spin and yoga? Well, that's already been told to us. It's 15 over 100. So how this equation is that the probability of event B given A has occurred is going to be 15 over 100 divided by 48 over 100. This Venn diagram has already told us the numerator. Whereas in the previous two examples for number 1 and 2, we had to find the probability of A and B. All right, we know the probability of A and B. It's 15 out of the 100. Take yoga and spin. All right, I would like you to do number 4 now. you always want to ask yourself when you're doing this conditional probability, do we know what the probability of A and B is already, or do we have to find that in the numerator of this formula? Okay, so let's look at this one together. Of the 30 students in Mrs. Smith's class, 15 are athletes and 9 are in the band. 3 of the athletes are also in the band. If one student is chosen at random, find the probability that the student is in the band if it is known they are not an athlete. All right, so A is not an athlete because that's what's given to us. Okay, and what we're being asked for is to find the probability that the student is in the band. Student in the band. Okay, now let's see what we know. We know that we've got a Venn diagram here. So we've got athlete. I'm going to make a music note for the band and then both. Okay, we've got 13 athletes. 9 are in the band. All right, and 3 are in both. So these numbers are a little off, right? 13 athletes, but 3 are in both. Let's try this again. Okay, athletes, band, both. Okay, so we know 3 are both, okay, in the band and athletes, which means that 10 are just athletes and 6 are just in the band. So we're trying to find the probability of B given A. So what is the probability of A and B divided by the probability of A? So what is the probability that you are not an athlete? All right. What is the probability that you are not an athlete? All right, is what P of A is asking for. Right? And then probability of B is the student being in the band. All right. So, probability of A and B is the probability that they are not an athlete and they're a student in the band. So that means it's 6 out of 30. Okay? 6 students are in the band that are not athletes. All right? And then probability of A is not an athlete. So the key thing on this is the probability of A is going to be 17 out of 30. Okay? It's going to be 17 out of 30. That's how many students, all right, are not an athlete. And we get 6/17 as our answer. All righty. So now we need to talk about two-way tables. Two-way tables are tables that record data that pertain to 2 different categories. Okay, the table shows the results of a poll of 50 randomly selected students who are asked whether they prefer to watch hockey or football. Find each probability. So the first thing when you're given a two-way table is you want to figure out totals. So based off of this here, we can see that we have 28 total boys, and here we have 22 total girls. Here we have 24 that prefer football, and here we have 26 that prefer hockey. So the question is, what is the probability that they prefer football given they're a girl? This means given. Okay? So we need to recognize that prefer football is a B and girl is A. Prefer football is the B and girl is the A. So let's think about this. What is the probability that we have a girl? Well, the probability that we have a girl is 22 over 100. Okay? Probability that they prefer football, all right, is what? Well, We know that that's 24 over 100. But do we need that? Well, let's see. Probability of A and B. So what's the probability that they're a girl and they prefer football? Well, that's actually 6 over 100. So we don't even need to know this, all right? Because now we can just plug it into the formula, all right? Where the probability of B given A is going to equal 6 over 100 divided by 22 over 100. So we get 6 over 22, which simplifies into 3 over 11. So two-way tables typically already give you that probability of both events occurring. Go ahead and try part B now. All right, so here we're being asked to find the probability of a boy given that they prefer hockey. So once again, this symbol means given. This is B and this is A. So the probability of A, all right, the probability that they prefer hockey is 26 over 50. Oh, and I just noticed these should all be 50s up here. Sorry, not hundreds. Oy. I added them double time. All right, so it's 26 over 50. Then we can ask ourselves, what's the probability that they like hockey and they're a boy? That's going to be 10 over 50. All right, so then we're going to be given the probability of B given A is equal to 10 over 50 divided by 26 over 50. And so our answer will be 10 over 26, which is 5 over 13. So there are our answers. All right, let's look at another table together. The table shows the results of a poll of 150, okay, so that's important information, randomly selected middle school students who are asked if they like French. So the first thing you want to do is you want to add up all the totals of the column and table. So based off of this, the total number of students who preferred French was 82, all right, which means that the total number of students who preferred Spanish were 68. Now, the total number of sixth graders was 42. The total number of seventh graders was 37. All right, and the total number of eighth graders was 71. All right, so A, what is the probability of a seventh grader who takes French? All right, so we know that this is our A and this is our B. All right, so our probability of A is that they take French. So we know that that's 82 out of 150. All right, now the next question is how many are seventh graders and take French? So the probability of A and B and that's going to be 25 over 150. So what we're going to get is we're going to get 25 over 150 divided by 82 over 150. So we get 25 over 82 as our probability. Now, something very important is that instead of it saying who here, this would have had to say given to solve it this way. But what's important is that would be the answer if it's a seventh grader given they take French. But they just asked for a seventh grader who takes French. That answer would just be 25 over 150, which is 1/6. All right, so I read it as a seventh grader given they take French. but it didn't ask that, all right? If it was just what it was originally asked, the probability of a 7th grader who takes French, our answer would be 25 over 150, which is equal to 1/6. So it's important for you to recognize what they're asking. All right? I'd like you to do B, C, and D on your own now. All right. So in this case, the probability of A, which is the probability that you take Spanish, is 68 over 150. The probability of A and B is that you take Spanish and you're an 8th grader. So that's 33 out of 150. So our probability here of B given A is going to be 33 out of 68. Okay? For part C, the probability of A, which is that you're a 6th grader, all right, is going to be 42 out of 150. The probability of A and B, which is that you're a 6th grader and you take French, is 19 out of 150. So the probability that you take French, given you're a 6th grader, is going to be 19 out of 42. All right, last one. What is the probability that you're a 7th grader, given you take French? So the probability that you take French is 82 out of 150. Sorry about that. And then the probability that you take French and you're a 7th grader, all right, is 25 out of 150. So the probability that you're a 7th grader, given you take French, is going to be 25 out of 82. All right, the last thing we're going to talk about is frequencies. And there are 2 types of frequencies that we need to look at. We need to look at joint relative frequencies and marginal relative frequencies. Joint relative frequencies are the values in each category divided by the total number of values. Marginal relative frequencies are found by totaling each row and column. So you can make a frequency table, okay, based off of data. So for example, the table below shows the number of first class and coach class passengers on a plane who checked 1 bag, 2 bags, and no bags. Find the joint relative frequency and the marginal relative frequencies, then add each probability. Okay, so remember, you need to add up every column and row first. So there was a total of 30 first class passengers, and there was a total of 130 coach passengers. There was a total of 68 people who checked in 2 bags, 72 people who checked in 1 bag, and 20 people who checked in 0 bags. Okay? So, to find the joint relative frequency, you're literally going to find the frequency of that specific category divided by the total number of values. So with first class 2 bags, it's 16 over 160, which is 0.1. For coach with 2 bags, it's 52 over 160, which is 0.325. And you would do that for each, and you get 0.075, 0.375 here. With 0 bags, it'd be 2 over 160, which equals to 0.0125. With 0 bags for coach, it's 18 over 160, which equals 0.1125. And these are all our joint relative frequencies. Now, to find the marginal, you add up. So this would be 0.425, this would be 0.45, this would be 0.125, this would be 0.1875, and this would be 0.8125. And they should all add up to 1 because probabilities all add up to 1. Now you can use these frequency tables to answer probability questions. So let's see how. So what is the probability that you have a coach class passenger that did not check in any bags? All right. So a coach class passenger that did not check in any bags. Well, that's this table right here. So 0.1125. All right. So some of them directly read from our table. Let's look at C though. What is the probability that you have a coach class given that they checked in one bag? So this is our B and this is our A. So what's the probability that they checked one bag? Well, that would be this value, okay? 0.45. Then we have to find what is the probability of A and B. So what's the probability that they checked in one bag and their coach? All right, well, that would be this value, 0.375. So to find the probability of B given A, it's 0.375 divided by 0.45, which ends up being 0.83. And typically, when you're dealing with frequencies, you're going to convert it into percent form. I would like you to do B and D on your own now.